Okay, this is weird, but anyway, I hope you finished off the sections on similar triangles and on Pythagorean theorems. So the section on Pythagorean theorem, we were dealing with right angle triangles. And we said when you have a right angle triangle, if you know two sides, you can find the third one. So if we know that this was 3 and this was 4, we could use Pythagorean's theorem, a squared plus b squared equals c squared, and we could figure out what the c was. But what if you want to know an angle? Or what if you want to know a missing side, but you only know one side and not two sides? That's where trig comes in. So, I said the other day in class when we were talking, I said that what they found was that by doing lots of experimentation, they found that this angle, based on the ratio of one side to another side, this angle would be the same thing. For example, if this is what we call the reference angle, this is the angle we want to find, and the ratio of this side over here, which is the opposite side, and the ratio of this side over here, which is the hypotenuse side, if it was 1/2 or 1/2, then this angle always worked out to be 30 degrees. This is where that whole SOHCAHTOA thing comes in. This ratio of opposite to hypotenuse is what we call the sine ratio. So the sine ratio is opposite over hypotenuse. There's another ratio that is cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So this is where SOHCAHTOA, S-O-H, SAW, CA, C-A-H, for cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So in this triangle, actually this is a crappy one, but in this triangle, this side would actually work out to be the square root of 3. And so if I was looking for what is the sine ratio of this 30-degree angle, it would be the opposite side over the hypotenuse side. If I was looking for what is the cosine of the cos ratio, using that 30-degree reference as my reference angle, cos of 30 would be the adjacent side, and this is the adjacent side, would be the adjacent side over the hypotenuse side. And finally, the tangent ratio using that 30-degree angle would be the opposite side, which is 1, over the adjacent side, which is root 3. So you can always say, listen, the cos ratio of this angle is always means equals the whatever the adjacent side is over whatever the hypotenuse side is. So we're going to break these down over the next few sections, and we're going to look at each ratio individually. Now, in my head, sine's usually first, but they actually start with tan in your book because they're weird. So we're going to look at some of these examples, and a lot of this we're going to be able to do on our calculators. Harriet came with me. It says, find that in example 1, if you look in your books, we're in section 6.3. If you look on your books on page 236, yes, I keep leaning down because my book's down there, sorry. It says, find the tan ratio for 40 degrees. Now, remember back earlier when we were doing an example, we said if this was your 30-degree angle, the opposite side is always 1 and the hypotenuse side is always 2, so that the sine ratio of 30 degrees is the opposite side, which is 1, over the hypotenuse side, which is 2. Well, if you divide 1 over 2, you get 0.5. And if you go to your calculator, and most of you have a good calculator, and so you'll be able to hit your sine button, which says sin on your calculator. Sine of 30 degrees and you hit equals, it will actually say on it 0.5. That is the ratio. The ratio of the opposite side divided by the hypotenuse side for a 30-degree angle is 0.5. So when they want you to do that for tan of 40, it's really simple. You just go to your calculator and you hit the tan button and you put in 40 and you hit equals, and you should get 0.839, and it keeps on going and going and going. Just round it off to whatever they tell you to round it off to. They say in the textbook to 3 decimal places, for example, 1. And it really is just a matter of going to your calculator and actually just putting into your calculator tan of 40 is, and then just put it in your calculator and it spits out the answer. So no work to show, yay for some of you. No work to show, it's just playing with your calculator. For those of you who have what I call a backwards calculator, you know who you are. You actually have to put that in backwards. You have to put 40 and then hit your tan button, and then you get that answer. If you try this on your calculator and you don't get this angle, it's because your calculator is probably not in degrees. Your calculator needs to be in something called degrees. On my calculator in the window, it has a little DEG to tell me it's in degrees. If it were in a different format, like radians, there would be a little RAD in the corner. Some just put a letter D. They don't put the whole DEG, they just put D. So if you can't get this on your calculator, check and see what mode your calculator's in. It should be in degrees. If it's not, you need to change it. And if you don't know how to do that, then we need to talk over Google Hangouts or through email or contact me in some way. Okay, so for example 1, it's the same all the way through. They want to know the tan angle, the tan ratio of 55 degrees. So you literally just go to your calculator and put tan of 55, and it's 1.428. Be careful when you round it off to 3 decimal places. You have to use proper rounding rules. The next section is still just using your calculator. Example 2, sorry, not the next section, the next example. The next example is still just using your calculator. There's absolutely nothing to show. If you hear little clicks in the background, that's just my dogs running around my feet. There's no work to show, but how it looks is they say tan of some angle is 1.782. So what that means is, remember, tan is the opposite side over the adjacent side. So what they mean is, in whatever triangle this is, if this is the angle I want to know, if this is angle A, if they take the opposite side, whatever that is, and they take the adjacent side and they divide them, they get 1.782. What they want to know is, what angle would that be if when I divide the opposite side by the adjacent side, I get that? So it's still just a matter of calculator work. All you have to do is go to your calculator, but instead of just hitting tan, you have to hit second function or inverse. I don't know what your calculator says, but you just hit second function tan of 1.782 and you hit equals, or sorry, you have to hit second function tan, I did not do that, of 1.782, and I get 60.7. We're going to round that off to 61 degrees. So A is 61 degrees. What that means is this angle right here should be 61 degrees. So again, when you hit like shift tan, what it looks like is that you're hitting, it's a little tan with a -1. It's actually called arc tan, but that's a really old word for it. They don't use that so much anymore, but that's what it's called. So arc tan of 1.782. So you hit shift tan of that and it'll spit out the number 61. Again, you should try that on your calculator. Make sure you know how to do it. If you have a backwards calculator, again, you're doing it backwards. You're going to do 1.782, shift tan, hit your equals. Again, you should be able to get 61 degrees. If you can't get 61 degrees, you have to find out what you're doing wrong somehow. Right, so all of that is just calculator work. So once you figured out how your calculator works, then they're going to throw problems at you. So example number 3. Example number 3, I got my textbook now. Example number 3 on page 237 has a triangle. And my great drawings again. They have, this is A, this is B, this is C. Here's your right angle. They have that this is 3 and this is 4. They want you to find tan of C. So they're not looking to figure out what the angle is. They're not looking to figure out what that angle is. They just want the tan ratio. Remember that tan is opposite over adjacent. Have I said that enough in this video yet? Tan is opposite over adjacent. So from angle C, the opposite side would be 4, and the adjacent side would be 3. So tan of C is 4 over 3. That is all they want in the first part. So when they ask for the tan ratio, they just want the fraction. You can, if you want, you can do 4 divided by 3 is 1.333, and it keeps on going forever. You can put it that way, but most of our calculators can handle fractions. So if you just leave it as a fraction, that's fine, because in the next step, now they want to know, okay, so if the ratio, if the fraction of opposite over adjacent is 4 over 3, now they want to know what would angle C be? How many degrees? Would this be a 20-degree angle? Would it be a 40-degree angle? What would it be? So to figure that out, again, you can either have it this or have this. It doesn't matter. So if I have, hopefully you can still see this, if you have tan of C is 4 over 3, and you want to know what C is, again, you want to get C by itself, so you have to move the tan. Whenever you split the tan up from its angle, when you move it over here, it's going to be this arctan of 4 over 3. Whenever you're trying to find the angle, whenever that's the piece that's missing, you're going to be hitting that shift or that inverse button. So you're going to hit shift tan of 4 over 3, and when you round it off, you should be getting 53 degrees. Okay? So you should try that with your calculator. Make sure that you can actually get those numbers to come up in your calculator before you start to do actual questions, because here you know what the answers are supposed to be. Hi, Wicket. All right. Yeah. I was going to let Wicket say hello, but he didn't want to come. All right. So the last, no, not the last, one of the examples, example 4. Example 4 gives you a triangle, and it says this is P, this is Q, and this is R, and you got a little right angle triangle there. And we have, oh my goodness, I'm getting old and the light is terrible. 8 and 5. And so first, they want you to find tan of P. So this is P. I just can't write very well. So this is P. So tan of P would be the opposite side, which is 5, over the adjacent side, which is 8. So tan of P is 8. Then they want to know, okay, what's the measurement of that angle then? Is that a 42-degree angle? What's that angle? So if I want to know what P is now, I'm going to bring my tan over here, and that's going to be that arctan, or that shift or inverse or whatever button you're hitting on your calculator. So you're going to hit shift tan of 5 over 8. So if I do shift tan of 5 over 8, I get 32 degrees. So this angle right here is 32 degrees. Now, if all we wanted to know was angle R, we could figure that out and we wouldn't need any big fancy trig, because we know in a triangle all angles add up to 180. So you could just do 180 minus 90 minus 32, and that would tell you what R should be. But, of course, they don't just ask that. They want to know what is the tan ratio for angle R. Remember the other day when we were working, we were identifying which side was opposite and which side was adjacent, and I said it depends on what your reference angle is. So if angle R is what we're trying to find, then from angle R, the opposite side is now 8, and the adjacent side is now 5. So the tan ratio for angle R is 8 over 5. So if I want to know what angle R is, when I move this tan over here, it becomes arctan of 8 over 5. So I just go to my calculator, I hit shift tan of 8 over 5, and it is 58 degrees, which makes sense because 58 plus 32 is 90, which it should be. These two angles should always add up to be 90 degrees, and they do, so I know I must be right. All right, I think I'm finally at the last example, guys. So example number 5, whoa. Okay, so the whiteboard's not that stable. So I'm no more serious on a video than I am in class, all right? So for example 5, they give us a triangle and they give us J, K, and L. And they tell us that this angle is 30 degrees. So this time they're actually telling us what the angle is. And they're telling us that this side is 10. And in the question, they want to know the length of K to L. So they want to know the length of K to L. So they want to know this side. So I'm just going to call it X because that's what they want to know. That's my unknown. So that's what I'm going to call it. So I'm going to set this up just like the previous sections. I'm going to say tan of my angle is, so remember is always means equals. I'm going to say tan of my angle is the opposite side over the adjacent side. So I'm going to say tan of 30 degrees is my opposite side. Well, opposite this angle is 10 over my adjacent side, which is X. So now I have to solve for X. So the first thing I'm going to do is over here, I don't have any unknowns. I just have tan of 30. So I'm going to go to my calculator and I'm going to put tan of 30 degrees. And that tells me 0.577, and it keeps on going, is equal to 10 over X. Now we know how to solve something when the variable's in the bottom of the fraction because I've taught you this. In order to get the variable out of the bottom of the fraction, you have to multiply this side by x, so you have to multiply this side by x, because whatever you do to one side, you have to do it to the other. I hope you are at home saying it out loud with me right now. So 0.577x equals 10, because those x's canceled. So now I want to get the x by itself. So this is where I would ask one of you to tell me what to do, but I can't. And the dogs won't answer me. So we're going to divide by 0.577 so that x is by itself. So we're going to divide by 0.577. So I'm just going to my calculator and I'm going to do 10 divided by 0.577. And I'm going to get 17.3. Now pay attention to where they want you to round it to. Do they want you rounded to the nearest tenth? Do they want you to round it to the nearest unit? Where do they want you to round it to? Okay, so that's the lesson for section 6.3. So somewhere on the assignment with this video should be a list of questions you have to do. So you go and do the questions before, I would say before 3 o'clock if you're wise and if you're smart. If not, I'm going to have to nag you. Don't make me nag you. So before 3 o'clock, if you could just send me a picture or a scan of your homework done. Again, I'm not going to be checking all your answers. The answers are at the back of the book. You check them and make sure you're doing them right. So I'm just going to, I just want confirmation that you did it. So when you send it to me, I'm just going to check your name off saying, yes, you did it. So don't forget, every day be filling in your attendance. Every day there's going to be a video probably, or at least every day or every other day. And then there will be work to do. If you have questions, please either give them to me on Google Hangouts or private message me, send me an email, whatever. If a lot of you have the same question, then I'll make a little video on how to do that. If it's just something that I can answer over Google Hangouts, then I will. If I have to make a video, then I will. Once we get to a test, we'll talk about how that's all going to work. So for now, watch the videos, do the questions that are listed on the assignment there somewhere on your page. Once you finish it, send it off to me and you're done. You finish it by 9:30 in the morning, then you're done at 9:30 in the morning. Okay, so thanks a lot. See you tomorrow. Well, I won't see you. I'll pretend to see you tomorrow. Okay, bye.